Cave is the least known environment to us. We don't have that much experience in robotics in caves, so it will be kind of surprise to us. Will there be more space to fly, or small holes somewhere?
In Tunnel, we learned a lot. We learned that testing is very essential. We need to be in representative environments, testing the system, various aspects of it, from perception to autonomy to communication to mobility. In Urban, we put that in work. We had our various systems in various field sites to not specialize it to a certain point solution, but rather handle challenges across a wide range of different environments.
In principle, our approach is a unified system of walking and flying robots for any environment. But we bring incremental pieces of this puzzle as we go from tunnel, urban, cave, and so on and so forth. So for the cave, we anticipate more vertical. For urban, we anticipated more horizontal exploration. Here, we emphasized a lot on the ground robots and the legged systems. And on cave, we plan to emphasize much more on the flying and on the co-deployment between flying from the ground robots.
We're probably going to some cave in Taiwan, having a better strategy to explore those kind of environments, and of course maybe testing some communication situations. The material on the wall are different. The structures are maybe vary a lot. So we'll definitely look into that. If you want to develop your robots in a real environment, we have to have some basic expectation, basic knowledge of the environment, I'll say.
We changed our communication strategies, have some new communication nodes. We have a drone that's new, that's optimized to fly inside, and so it has props underneath that make it as narrow as possible.
Again, we don't know what the environment is going to look like, so it's hard for us to know in advance which of these platforms is going to perform the best, but that's kind of our approach, is to come up with all kinds of different designs and see which one perform the best. We actually want the most distinctive robots award in the tunnel circuit, so I think we are on good track.
One of the things here is we tested out our ground systems. We noticed that mobility is actually a major issue, and we foresee that in cave, the mobility will be even worse than what we see in urban. Moving forward, what we're going to look more towards is aerial vehicles. So we've already been having some aerial vehicles in development. And we also have the spirit where if things don't work, we just change them on the fly.
Visualization, understanding where the robots were and where they needed to go next was the biggest challenge. We're going to improve the mapping data we have available on our base station so it's easier to see.
Our comm system's improved. We're going to deploy beacons and have a much better comm solution. I've also looked a lot at our autonomy and actually doing a lot of collaborative types of behavior. So before we had sort of a topological planning approach, now we've got more of a frontier exploration approach and a lot more difficult mobility transitions. We've got some tracked vehicles, some large and small tracked, as well as some aerial platforms.
In Tunnel, we were quite focused on having the robots communicate very effectively, but they weren't extremely autonomous. This time, when a robot loses communication, it just drives off and comes back and reports things, and that worked really well. And so I think to enable that for the cave event, we're expecting really rough, uneven terrain, and so I think we're going to focus a lot on making that autonomy work in that situation.